Hello everyone and welcome. I'm excited to introduce you to today's presentation on online training and courses. The focus will be on Spark and Python, two powerful tools for data processing and analysis. Over the next few minutes, we'll explore the key concepts, practical applications, and how you can leverage these technologies. Let's get started. Let's start by understanding what big data actually is. Essentially, big data refers to extremely large data sets that are too complex to be processed with traditional data processing tools. It's all about managing and analyzing vast amounts of information to uncover insights and drive decisions. Moving on, Hadoop and HDFS are foundational technologies in this space. Hadoop is an open-source framework that allows us to store and process big data efficiently across distributed systems. HDFS, or Hadoop Distributed File System, is the storage layer that splits data into manageable chunks across multiple servers, ensuring scalability and fault tolerance. Next, we have Apache Spark, which has revolutionized big data processing. Spark is a fast, in-memory data processing engine that enables real-time analytics and machine learning applications. It complements Hadoop by providing quicker processing capabilities, especially for iterative algorithms. And finally, we're going to explore the Spark and Python combination through our PySpark course. This course is designed to teach you how to harness the power of Spark using Python, making big data analytics more accessible and intuitive, especially for those already familiar with Python. Throughout this presentation, you'll see how these technologies fit together and form the backbone of modern big data solutions. All right, now let's talk about setting up Python with PySpark. This is a crucial step because it allows us to combine the simplicity of Python with the power of Spark for big data analysis. By working with Python and Spark together, we can efficiently process and analyze large datasets, which is essential for real-world consulting projects. These projects often mimic actual business scenarios, giving you practical experience. Next, we'll look at different setup options. First, there's the Databricks platform, which is a cloud-based environment optimized for Spark. It's very user-friendly and great for collaborative work. We'll explore how to get started with Databricks to leverage its capabilities. Then, we'll cover setting up locally using VirtualBox. This is a good option if you want to experiment on your own machine without cloud dependencies. It's a bit more hands-on but very educational. Moving on, we'll discuss setting up PySpark on AWS EC2 instances. This approach is popular because it offers scalable cloud resources. I'll guide you through getting everything configured on Amazon Web Services EC2, which is ideal for handling big data workloads. Finally, I'll introduce you to AWS Elastic MapReduce, or EMR. This is a managed service that simplifies big data processing in the cloud. You'll learn how to utilize EMR for large-scale data analysis, making your workflows more efficient. All these options give you flexibility depending on your project needs and resources. The key is understanding how to leverage these platforms effectively to analyze big data and gain insights that matter. Now, let's dive into setting up an AWS EMR cluster and explore some fundamental concepts of Spark data frames. First, we'll look at what a Spark session is and how to effectively use it. Think of the Spark session as your gateway to all Spark functionalities. It's the entry point for creating data frames, executing SQL queries, and accessing Spark features. Next, we'll see how to create data frames using PySpark. This is essential because data frames are the core data structure in Spark for handling large-scale data processing efficiently. Moving on, we'll cover how to read and write CSV files, which are common formats in data workflows, and how to read JSON files using PySpark, enabling us to work with semi-structured data. We'll also explore data fabrication techniques within PySpark, which are useful for generating synthetic datasets for testing or modeling. Then, we'll look at joining two data frames, an operation fundamental to combining datasets based on common keys, much like a relational database join. Additionally, we'll examine UDF functions in PySpark, which serve as replacements for Pandas Lambda functions when we need custom transformations at scale. We'll also discuss how to use the Spark Submit command in the terminal to run your PySpark applications seamlessly. In real-world scenarios, customizing the Spark logger is vital for effective debugging and monitoring, so we'll see how to tailor the logger library to fit project needs. Creating schemas and adopting user-defined schemas is another key point, as it helps enforce data structure and improve performance. Finally, we'll look into the utility of function libraries in PySpark, which promote code reuse and modularity. Throughout this segment, remember that these concepts build the foundation for scalable, efficient data processing in the cloud environment, aligning with our overall goal of mastering big data workflows. Now, let's dive into the Spark Data Frame project exercise. Here, we'll be exploring how to leverage Spark's mlib to build powerful machine learning models. mlib is a really robust library that allows us to perform scalable machine learning tasks directly on Spark. We'll start with linear regression, which is great for predicting continuous outcomes. For example, predicting house prices or sales figures. Then, we'll move on to logistic regression, which is our go-to method for classification tasks, like determining whether a customer will churn or not. Specifically, we'll focus on classifying customer churn using logistic regression. This is a common problem in business, where understanding why customers leave helps us improve retention strategies. By the end of this slide, I want you to see how these models fit into real-world scenarios and how Spark's mlib makes it easier to handle large datasets efficiently. This is all about empowering you to create scalable, accurate models that can drive impactful decisions. All right, let's dive into decision tree and random forests. These are powerful tools for classification tasks. With decision trees, we split data based on feature values to make predictions, and they're quite interpretable. Random forests build multiple decision trees and combine their results, which generally improves accuracy and reduces overfitting. Now in Spark, you can leverage gradient-boosted trees, or GBTs, which build trees sequentially to correct errors from previous ones. This method often delivers very high predictive performance, especially with structured data. Moving on, Spark also supports random forests for classification. They're versatile and scalable, making them great for handling large datasets in distributed environments. Next up is k-means clustering, a popular unsupervised learning technique. It groups data into clusters based on similarities, which is useful for segmentation, customer profiling, and so on. And finally, collaborative filtering is a key approach for recommender systems. It analyzes user-item interactions to suggest new items that a user might like, based on the preferences of similar users. This technique is fundamental for personalized recommendations in many platforms. All of these methods connect back to our overall goal, harnessing Spark's capabilities to analyze and extract insights from big data efficiently and effectively. Now, let's dive into how we can use natural language processing to create a powerful spam filter. The idea is to leverage Spark's capabilities combined with NLP techniques to identify and filter out unwanted messages effectively. This approach is especially useful in handling large volumes of data, like emails or social media messages, in real time. We'll be working with Spark streaming using Python, which means we can process data on the fly, making our filter both fast and scalable. One of the exciting parts of this presentation is showing how we can harness the full power of Linux within a Spark environment to optimize our processing. Imagine analyzing streams of tweets as they happen. This is where Spark streaming truly shines. By applying NLP to these real-time data feeds, we can detect spam or malicious content instantly, helping to maintain healthier online environments. So, the key takeaway here is that combining Spark, Python, and NLP not only makes real-time data analysis feasible, but also incredibly effective for tasks like spam detection. This is a perfect example of how big data tools can be applied to solve practical, everyday problems in digital communication. Thank you for your attention. If you have any questions or would like to discuss further, feel free to give us a call at either of these numbers. +1 917 780 19379 or +91 9650 788 You can also visit our website at techgenx.org/SparkPython, PHP for more information. Once again, thank you very much for your time and interest.